We will solve this problem from a specimen paper, new syllabus of the IB standard level maths on bivariate stats. The topic is called bivariate statistics because we have two measures of the same element of a population. In our case, X is a number of boxes and Y is a production cost according to the number of boxes. So we have our results in this table, and we'll see first how we introduce data in our GDC. We need to create the two lists. First, I have in my GDC, I need to clear up the lists that I have already in my GDC. Clear. And then slowly we put in the numbers that are in our table. Here is our data. Let us see now how we create the regression line of Y on X. So under calc, regression line, option number 4. I need to make sure that the two lists are correct. So my X list corresponds to L1 and the Y list corresponds to L2. I need to change them accordingly. And then what can prove very useful is to store the regression line in a variable. My variable will be called y1, so it will be defined like a function, a line that I can use later, because in the subsequent questions I'll probably be asked to use this regression line to predict something. That's why I chose to store the regression line instead of typing it on my piece of paper. So I'm going to store it under the variable y1. And here I calculate the regression line. So here is the equation of the regression line copied from my GDC to 3 significant figures. Interpret the meaning of the gradient. The gradient is additional cost for producing one more box. So if X becomes X plus 1, then Y will increase by $10.7. So this is how what is the cost of producing one more box. Y-intercept. Y-intercept is the amount I need to pay for producing 0 boxes. So it's an initial investment that I need to do to start my production. It is called a fixed cost, but we don't really need to know this term from economics. It's enough if we explain in our own words. Now we're going to look at question C. Estimate the cost of producing 60 boxes. Now to produce 60 boxes, I can just replace X by 60 in my equation, or remember how we store the equation in my GDC, so I can use a table of values for X equals 60 to produce the answer immediately. And let us see how. So this is my line of regression. And now I'll go under table of values. First I check under table set that I am allowed to insert the value of X by myself, which I am. Otherwise I'll put it on ask. So under table I want the value of Y when X is 60. So I'm going to type 60, and here it is my answer. So my answer for C will be $760. Now, in order to answer question D, I can either use my GDC or do it algebraically. So an algebraic approach to it will be factory sells the boxes for $19.99 each. So how much I earn from selling the boxes is 19.99x if I sell X boxes, and in order to make a profit, it needs to be bigger than 10.7x plus 121. So I need to find what is the minimum value of X. X is an integer as a solution of this equation. I can solve this algebraically, or I can solve it using my GDC. And let us see how. So I quit, and then under y equal, I put the second equation, y equals 19.99x, and the challenge would be to choose a view window so that I can see the solution. We'll now find the intersection point of the two graphs. First curve, second curve, yes. So the first point will be x equals 13, the first integer. So my answer to this question will be x equals 13 from GDC. Next question asks to estimate the cost of producing 5,000 boxes. I can't estimate this using my regression line because 5,000 is outside the range of my x values and number of boxes. And this would be called extrapolation. It's not appropriate to use an x, to use this regression line to estimate the value of y for an x which is outside the domain. So it's not appropriate. Second question under E asks of the appropriateness of using the model to estimate the number of boxes when the total production cost is 540. So I'm given y and I must to estimate x using y. I also can't use this line of regression because this is the line of regression of y on x and is used to estimate the value of y when x is given and not inversely. There are a couple of things useful to know, and we are going to look into this. They are not needed for this question. So remember when we found the regression line of y on x from the two lists. I hope this is stored in y1 and will stay there from the previous question. Calculate, yeah, so they are the same steps from the previous question. We found the correlation coefficient. So the correlation coefficient is 0.97, showing a strong positive correlation. Sometimes in an exam you'll go and you'll see that if you do the same steps, you will not find R here, and you'll just have A and B. So don't panic. The reason is that when you reset your GDC, there is an option called Stats Diagnostics, which is here, and it's going to be on/off automatically when you reset your GDC. So you need to turn it on when you go in the exam. After we get the correlation coefficient, sometimes it's very useful to look at how the data looks like. So we need a scatter plot of our data. So I'm changing the view window to get a window appropriate from my data. And then I'm going to use the scatter plot. So quit, and then scatter plot, which must be on, yeah, to graph. And it is, it said, very useful very often to look at how my data is placed.